சொல்லு. ரஃப் பிரேக்கிங் உனக்குலாம் மன்னிப்பே கிடையாது. ஒன்லி பனிஷ்மெண்ட். இல்ல அது பார்க்கலன்னா கூட உனக்கு ஒன்லி பனிஷ்மெண்ட் தான். வந்து 1 minute தான். சரி இது வரேன். நிறைய பிபிடி சாங்ல இருக்கு. Crash sheets வரலாம். PPTs crash sheets. Right? Those are online. Are you able to see the screen?
Yes, sir.
Okay. So we'll get started. Class முடிஞ்சது. அந்த ப்ராப்ளமா இன்னும் வரலையா? ஹைபோட்டென்யூஸ் கண்டுபிடிச்சு வை. நான் கேட்குறப்ப ஓகே. Where are others? Everybody went up. Yeah, who are there in the second batch? Only you. No? Then it is fine. Listen. So the next topic that we'll see is motional EMF from Faraday's laws. Okay. So we know that for EMF to get generated, right? For EMF to get generated, there should be a change in flux taking place with respect to time. Am I right? So there should be a change in flux taking place with respect to time. So flux is equal to BA cos theta. So flux is equal to BA cos theta in the sense the flux can change if either B is changing or A is changing or theta is changing. So what can happen here is, in this case, B will be constant and theta will be constant, but what will change? The area will change with respect to time. So for that, the system is going to be developed in such a way that you're going to have a rectangular metallic frame, right, on which there is going to be a wire that is going to slide, right? There's a frictionless rectangular surface on which there is a wire that is going to slide. And in this wire, we are going to generate the EMF by putting it into motion. That is the reason why it is called as motion EMF. Okay. So the first thing that is to be noted is this wire has to move with the velocity of, with a speed v, which is constant. It is not going to have any acceleration associated with it. Right? Now, if you see, if I take the length of the wire to be L and the magnetic field to be into the plane, right? This point is P, this point is going to be Q. Now the question is, our job is to find out what polarity P and Q are going to take so that the current is going to get generated, right? Now observe. Now observe. Magnetic field is into the plane, right? And when the conductor is moving in this direction, the flux is decreasing. What is happening? The flux is decreasing, right? When the current is moving in the left direction, flux is decreasing. When flux is decreasing, what pole should get generated? It should start generating the opposite pole. So, since the magnetic field is into the plane, we are north pole. So, we are north pole. Since the field is being received by this surface, what will happen is, and the flux is decreasing, it should generate the opposite pole as that of what we are. So since we are north pole, there will be a south pole that will get generated. So when it is south pole, the current should start flowing in the clockwise direction. So current starts flowing in clockwise direction in the sense, then Q should be at higher polarity compared to P. So Q should be at higher potential compared to P. Because current outside the conductor will start flowing from higher to lower potential, whereas the current inside the conductor will start flowing from lower to higher potential. Am I clear with this point? Right? So this is one way of finding what is a motional EMF. Okay. But the question is, this theory is fine. What about the magnitude of the EMF that is getting generated here? So for magnitude, E is equal to, we are going to write it as delta phi divided by delta T. But what is the flux that is associated with the coil? So length of the conductor is L, whereas this distance is X. So as V is changing, X is also going to change. So what is the value of flux that is associated with this coil? Flux is equal to BA cos theta. So B is how much? B only. What is going to be the area? Length into breadth. It is going to be L into X into cos of how much value? Cos of 0 degrees. So it is going to be cos of 0 degree and it is going to be 1, right? So flux is equal to B into L into X. So what is the value of d phi by dt? d phi by dt will be equal to B into L into dx divided by dt. But what is dx by dt? It is the rate at which the distance is changing, which is nothing but the speed. So this will be equal to B into L into V. So from this, it is clear that the motional EMF is going to be equal to B into L into V in terms of magnitude. Means the potential difference between this point and this point is going to be this value. That will occur under what scenario? Only when the conductor is in motion. Am I clear? Right? So this is the value and the derivation for the value of the motional EMF. Just make a note of it. Done with this? Okay. Now what we'll do is, we'll discuss about the same motional EMF, right? We'll discuss about the same motional EMF, but with the help of the force experienced by an electron that is present inside a conductor. So if I talk about this conductor, there are going to be multiple electrons present in it. So when the conductor is moving in the leftward direction, what will happen is this electron is also experiencing a velocity in the leftward direction. And how is the magnetic field? It is so into the plane. So what I'm doing here is I'm discussing an alternate way, right? An alternate way to derive the same value of DLV. Right? We understood that this is going to be positive, this is going to be negative, but we'll give a better justification. So if I take that conductor and draw it separately, if the velocity is in this direction, right? So what is the force experienced by this electron? F is equal to Q into V vector cross B vector. So Q is going to be minus E into, what is this? It is going to be V vector cross B vector. Am I right? So velocity is in this direction, magnetic field is into the plane. So when I write V vector plus B vector, can I write it as minus EVB into, what is V vector? V vector is in the direction of minus I cap cross, what is the direction of K? What is the direction of B vector? It is minus K cap, right? So minus I cap cross minus K cap is going to be how much? So minus EVB into I cross K. So I cross K will be minus G. So minus of minus J will be plus J. So EVB times J cap, it's going to be the force that is experienced by the electron. Means this electron will start experiencing a force in the upward direction, meaning the negative charge will get concentrated at the top, due to which this will have negative polarity and this will have positive polarity. And that is what we derived using Lenz's law also. So using Lenz's law, I told you, the topmost point is negative, the bottom point is positive. You can either use Lenz's law or the Lorentz force concept to derive the same expression. I mean, derive the polarities. Is that point clear? Right? Hence, this is going to be negative and this is going to be positive. And for the value of BLB, you can still use the same logic of Faraday's law of electromagnetic induction. That is E is equal to delta phi B divided by delta T. Is the point clear? Electron. Electron இங்க போறதுனால தான் இங்க நெகட்டிவ் வருது. Because the conductor is moving in this direction, the electron is experiencing a force in the upward direction. So more amount of electrons will go and settle at the top. As a result of this, there will be negative charge generated here and positive charge generated here. Because current will flow from higher to lower potential outside the conductor. This is the conductor. So current should flow from higher to lower outside the conductor, and inside it will flow from lower to higher. I told this point yesterday, so remember. So current flows from higher to lower outside the conductor and lower to higher inside the conductor. This is it. Another logic. Current will move from higher to lower outside the conductor and lower to higher inside the conductor. அதே லாஜிக் தான் நேத்து நான் எக்ஸ்பிளைன் பண்ணடா 2 times சொன்னேனே. கன்ஃபியூஸ் பண்ணல. ஒரே ஒரு ஞாபகம் வச்சுக்கோ. Higher to lower potential is only outside the conductor. Lower to higher inside the conductor. புரியுதா? Did you all come? இது minus of minus is plus. I cross K is minus J. Minus of minus is plus. No? There is a minus here because of the electron's negative charge. எது plus J? Why shouldn't அப்படிதான் இருக்கும்? I cross K is minus J only. இங்க minus விட்டுரு. Minus of minus is I cross K is அந்த minus J தான் இது. So இந்த minus சேர்த்தா plus ஆகும். என்ன புரியல? I told you many times, right? Take the anti-clockwise direction. ஏன் எல்லாம் புதுசா கேக்குற? இன்னைக்கு தான் ஃபர்ஸ்ட் கிளாஸ் வர மாதிரி. I, J, K. I told anything in anti-clockwise is positive. I cross J is K. J cross K is I. K cross I is J. Anything in clockwise is negative. I cross K is minus J. அதனால தான் அங்க minus J போட்டு. Okay. This is there in vector algebra in math also. Anga kuda use pannum. The 10th chapter we'll study about it. Prida, are you clear? Those are online. Are you clear?
Yes, sir.
Okay. So next is we need to understand the concept of Fleming's right hand rule. Just a minute. So the next concept that we'll see is Fleming's right hand rule. Okay. So if you see, we already know about the right hand thumb rule. Right hand thumb rule gives you the direction of magnetic field due to a current carrying conductor. You know Fleming's left hand rule. Fleming's left hand rule will talk about the force experienced by a current carrying conductor. Whereas Fleming's right hand rule will speak about the direction of induced current. It will speak about the direction of induced current that is set up in a conductor. Okay. And the conductor should move perpendicular to the magnetic field. So you can state it like this. So you take the first three fingers of your right hand, forefinger, central finger, and the thumb, right hand. So forefinger, central finger, and the thumb in such a way that forefinger, first letter is F. So forefinger is placed in the direction of field. The thumb is placed in the direction of motion of the conductor. Then the central finger will give you the direction of induced current. Are you able to understand this? Now, let's look at this scenario. You have North Pole here, South Pole here. The field is from left to right. Right, the field is from left to right, and there is a conductor that is placed here. The conductor is moving upwards. So what is the direction of field? Leftward. So direction of field is leftward. Motion of the conductor is upward. So the direction of induced current should be towards us. So when it is towards us, again, you're going to take this as positive, this as negative, because the current is going to flow from higher to lower potential. Am I clear with that point? Right? Motion of the conductor. Because for you to have the EMF induced, you need the conductor to be in motion. There is nothing like force. Okay, direction of force. Yeah, you can say direction of force. You're done with this? Shall I proceed? So this motional EMF using from Lorentz force, I've already taught you. Yes. So we'll try out some problems that are based on motional EMF. Okay, listen. So we'll see some problems that are based on the concept of motional EMF. The first one is the EMF induced in a conductor of length L moving with a velocity V perpendicular to the magnetic field is given as E is equal to BL into V, right? Induced EMF developed between the two ends of a rod rotating at its one end perpendicular to the magnetic field is going to be half BL square omega. This I will derive and show. Okay. So we have seen BLD only for a conductor which is moving in a linear path. There is a possibility for you to generate motion EMF when the conductor is rotating also. So rotating means it is going to be half BL square omega, right? So what is the unit used here? B is either Tesla or Weber per meter square, and L is going to be in terms of meter, velocity in meter per second, and angular speed is going to be in radian per second, and EMF is measured in volt. Okay, so having said this, let's look at the first problem. So the first problem is an aircraft with a wingspan of 40 meter flies with a speed of 1080 kilometer per hour. So length is how much? 40 meter. Speed is 1080 kmph. So 1080 kmph means 1080 into 5 divided by 18. So this should cancel this. How many times? 60 times. So you're going to have it as 300 meter per second, right? In the eastward direction at a constant altitude in the northern hemisphere, where the vertical component of the Earth's magnetic field is how much? Vertical component of the Earth's magnetic field is 1.75 into 10 power minus 5 Tesla. Find the EMF that is developed. So EMF is equal to what is the formula? So B is there, 1.75 means how much? It is 7 by 4. So 7 by 4 into length is how much? 40 into speed is how much? 300. So 4 and this will cancel 10 times. So 3000 into 7 is going to be 21,000 volt. Is it clear? 1 minute. Let me check the answer. 0.21 volt. Oh, okay. Sorry. I missed 21,000 is very high value. Even I didn't think of. So into 10 power minus 5 is there. No, I forgot that. 10 power minus 5 means 0.21 volt. See, 21,000 volt na flight pull, you imagine yourself. I'm sorry. Correction. Right. So EMF is equal to B into L into V. So B is how much? 1.75. 1.75 can be written as 7 by 4 into 10 power minus 5 is there. Into length is how much? 40 into speed is 300. So 4 and this will get cancelled 10 times. So 300 into 10 is going to be 3000. So 3000 into 7 is going to be 21,000 into 10 power minus 5. So how much will be the answer? 0.21 volt. 1, 2, 3, 4, 5. So it is 0.21 volt. Right? Shall I proceed to the next one? So second problem is a jet plane is traveling west at a speed of 450 meter per second. If the horizontal component of the Earth's magnetic field at that place is, so horizontal component of the Earth's magnetic field at that place is 4 into 10 power minus 4 Tesla, and the angle of dip is 30 degrees. So angle of dip is 30 degrees. Find the EMF induced between the ends of wings having a span of 30 meter. See, I cannot do this problem because Earth's magnetism I didn't teach you. So I cannot do this problem. Okay, so what you need to do is you need to multiply that horizontal component with cos of this value. Okay, anyways, don't worry. Sorry, tan of that value. You want me to explain? I'll do it. Explain Pantuma. Just a formula to Gupta. If anyone is preparing for competitive exam, it might help you. So I'll just tell you, listen. So whenever you have this kind of a problem where the wing is there, no? So for that, you will always take the vertical component of the velocity, vertical component of the magnetic field, right? Because that is the one which will contribute to the motional EMF. Because whenever you need the motional EMF, right, you need to have the magnetic field and the length perpendicular to each other. So here they have given the horizontal component, which is 4 into 10 power minus 4. So for finding the vertical component, right, there is an expression like this, which is given as tan. This is delta. Delta is what is called as the angle of dip. So tan delta is given as BV divided by BH. BV means magnetic field, which is vertical. It is a vertical magnetic field of Earth, and BH is the horizontal magnetic field. So which implies BV is equal to BH into tan delta. BH is how much? 4 into 10 power minus 4 into what is tan delta? Tan 30 is going to be 1 divided by root 3. Right? So the EMF is going to be equal to BV into L into V. So what is BV? This 4 divided by root 3 into 10 power minus 4 into L is how much? L is 30. And what is going to be the speed? It is 450. What you can do is you can rationalize it so that you'll have 3 in the denominator. So 3 will cancel this 450, 150 times. Okay. And then you can multiply, you will get the answer in terms of volt. Right? So I'm leaving that part to you. Am I clear? Eight, yeah. See, some 3.12 volt is the answer. Okay. Because angle of depth is not there, no, they should not ask. Shall I proceed? So try this one. A railway track running north-south has two parallel rails 1 meter apart. Calculate the value of induced EMF between the rails when train passes at a speed of 90 km per hour. The horizontal component of the Earth's magnetic field is 0.3 into 10 power minus 4 Weber. Actually, it is meter power minus 2 Weber per meter square. Okay. And the angle of dip is 60 degrees. So same logic. What is the answer? So length is equal to 1 meter speed is equal to how much? 90 kilometer per hour. So 5 by 18 into 90. How much will it be? It is going to be 25 meter per second. What is the value of B? 0.3 into 10 power minus 4 Tesla. And what is the angle of dip? It is going to be 60 degrees. So this is BH. So if you want BV, what are you supposed to do? So multiply this with tan delta. So 0.3 into 10 power minus 4 into tan 60 is going to be how much? Root 3. Let's see. So E is equal to BV into L into V. So what is the value of BV? So it is 0.3 root 3 into 10 power minus 4 into L is 1 and V is 25, right? So on solving this, so 1.3 into 10 power minus 3 should come. So 1.3 into 10 power minus 3. So 1.3 into 10 power minus 3 is what is expected. 1.732. Polama. Not this one. You can try this. So conducting rod PQ is in contact with metal rails RP and SQ, which are 25 centimeter apart, right? In uniform magnetic field of flux density 0.4 Tesla, acting perpendicular to the plane of the paper. Ends R and S are connected through a 5 ohm resistance. What is the EMF when the rod moves to the right with a velocity of 5 meter per second? What is the magnitude and direction of current through the 5 ohm resistance? So first find out the EMF. EMF is equal to B into L into E. What is the value of B? 0.4. L is how much? 25 centimeter is 1/4 of a meter. So 0.4 into 1 by 4 is 0.1. So 0.1 into 5. 0.5 should be the answer. 0.5 volt is getting generated across the ends of P and Q. Then how much will be the current through it? I will be equal to 0.5 by 5. So 0.1 ampere. Question is, what is the magnitude? Magnitude is 0.1 and direction of current through the 5 ohm resistor. So we have solved this case. When the conductor is moving away among P and Q, which one is going to be at higher potential? P will be at higher potential and Q will be at lower potential. So what is the direction of current? Anti-clockwise. I told you, no, current outside the battery will flow from higher to lower potential. So current inside the conductor will be from higher to lower potential. Current inside the battery will be from lower to higher potential. Since the potential difference is developed across P and Q, right, it will act as the battery. Current is going to flow in the anti-clockwise direction. Am I clear or not? Those who are online are able to understand what I told.
Yes, sir.
Okay. Just for the sake of understanding, I'm just going to write and show you. See, B is equal to how much? 0.4 Tesla. Resistance is going to be equal to 5 ohm. Right? EMF is equal to B into L into V. The value of B is 0.4. L is how much? 25 centimeter, which is 1/4 of a meter, into what is the value of V? V is going to be 5. So 4 and 0.4 will get cancelled in such a way that you will get 0.5 volt. So 0.5 volt is what you're going to get. What is the current? I is equal to E by R. So 0.5 divided by 5, which is going to be 0.1 ampere. So it will be 0.1 ampere. So what is the direction of current? Direction of current is in the anti-clockwise direction. Now the second part of the question is, if the rod moves to the left with the same speed, what will be the direction of new current? See, what will be the value of new current in the first place? New current will still be the same, but what will be the direction? Clockwise. It will be clockwise. So Q will be positive, P will be negative. So that is a part of the derivation that we did. Right? This is the one I told you. Right? So this is an example problem from your textbook. Okay, this is very, very important. Listen. A metallic rod of length L is rotated at an angular speed of omega normal to the uniform magnetic field. So there is a uniform magnetic field which is existing into the plane, right? Uniform magnetic field is existing into the plane, and there is a rod that is rotated so there is a rod that is rotated by there is a rod that is rotated by hinged at one of the ends by with what speed? With an angular velocity of omega, and magnetic field is into the plane, right? So what is the length of the conductor? So length of the rod is going to be L. So our job is to derive what is the EMF that is induced across the ends of this rod. Okay. So when this rod is rotating, what parameter among B, A and cos theta is changing? Because I know the formula for flux is equal to BA cos theta. So what parameter is changing? See, theta, don't get confused. Theta, it is not something related to rotation. Theta is the angle between the magnetic field and the areal vector. It is the area that is changing. Because with time, what is happening? It is increasing the sector's value. Are you able to understand what I'm saying? Right. So suppose at some instant, it has covered an angle of alpha. Let's say it has covered an angle of alpha. Then what is going to be the flux that is covered by this in that time interval t? So flux is equal to B into, I need to find out what is the value of A into cos of, I will write it as 0 degrees. Because I took B inside, I'll take area also inside. Right, but what about area? So when theta, like when alpha is equal to, see, when a complete rotation is made, what is the area? When alpha is equal to 360 degrees, what is the area covered? It is pi r square. When it is only alpha, what is going to be the angle? Pi by pi r square divided by 360. Right. So if I take this to be x, 360x is equal to pi r square alpha, sorry. Then x is equal to pi r square divided by 360 into alpha. Can I write it like this? So pi r square divided by 360 into alpha. So phi is equal to b into pi r square divided by 360 into alpha. But tell me one thing. Here, how much is the value of r? What is the value of radius? Radius is nothing but the length of the rod itself. Right, correct. Because the rod is hinged at one of the ends. So radius of the circular path is going to be L square divided by 360 into what is going to be the value of alpha when it completes one rotation is what we. So this is the value of phi. But why is this phi changing? The phi is changing because the value of alpha is changing. கரெக்டடா? நான் சொல்ற புரியுதா? Right. Now tell me, how should I write the angular displacement in terms of angular velocity and time? You know that alpha is equal to omega into t. Alpha is equal to omega into t. Here I think I made some mistake here, but pi r square divided by 360. Yeah. Thing is, here we'll take the angle in terms of radian. So you should not take it as 360, you will take it as 2 pi. Okay. Then what will happen is pi r square divided by 2 pi. So pi and pi will get cancelled. So you will have L square by 2. Purida. So B L square by 2 into alpha. See, pen is not writing properly. I don't know why. Okay, that is why it's coming as lines. So it is written as omega into t. Are you able to understand this point? So this will be B L square. See, I'm writing 2, it's writing like something else. B L square by 2 into alpha is omega t. This is phi, but I need EMF. What is EMF? d phi by dt. So EMF is d phi by dt means, right, d phi by dt. No, I need to differentiate this. So when I differentiate this, I will have B L square by 2 into derivative of omega t is going to be omega. And look at the expression that I gave you in the beginning. When a rod is rotating, the EMF generated across its end is going to be half B L square omega. That's it. Now you understood how you got it? This is a very important derivation. Okay. Or you can treat it like a problem also. This is a very important problem, so mark it as important. Chandrayaan landing la brain vela seyala. And this is also not working. I have to restart the system actually. Those who are online, I hope you could understand.
Yes, sir.
Yes, sir.
Land ana? Satellite la edhukku anupranga generally. Well, generally wide away satellite. Same thing. Moon analyst. South pole காமிச்சிருக்காங்க. மூணோட சவுத் போல் போயிருக்கு. We are the first to land in south. And it's a longer distance also. The trajectory it has to take is a longer path also. Last time அதனால தான் ஃபெயில் ஆச்சு. ஆமா 2019 செப்டம்பர்ல ஃபெயில் ஆகுது. This 3 டா இது சந்திரயான் 3 இது. எனக்கு 2 நல்லா ஞாபகம் இருக்கு. 1 எனக்கு தெரியல. 2 வந்து லேண்டிங் இதே தான். அந்த இது ரஃப் பிரேக்கிங் சொன்னல, அந்த டைம்ல இட் லாஸ்ட் த சிக்னல். சிக்னலே போயிடுச்சு. அதுக்கப்புறம் ட்ராக் என்ன இது ஏதாவது போய் கண்டுபிடிச்சா ஏதாவது பார்க்கலாம். பட் இட்ஸ் ஜஸ்ட் கோயிங் டு பி ஸ்டாட்டிக் தான் எனக்கு தெரிஞ்சு. இட்ஸ் நாட் கோயிங் டு ஹோவர் ஓவர் தி பிளேஸ். இட்ஸ் கோயிங் டு பி ஸ்டாட்டிக். லேண்ட் ஆகிறதுக்கு முன்னாடி இல்ல, தேர் வாஸ் சம்திங் யூ ரிமெம்பர் ஃப்ரம் 30 கிலோமீட்டர் இட் கேம் டு 7.4. அதில் ரஃப் பிரேக்கிங் சொன்னாங்க பத்தியா? அந்த ரஃப் பிரேக்கிங் டைம்ல இட் லாஸ்ட் த சிக்னல். It's experiencing a kind of either. It's not smooth. In the sense, it is experiencing some kind of what do you say, wobbling and all those things. And the 7.4 அப்புறம் வந்ததுக்கு அப்புறம் தான் it will take a smooth landing. அதனால தான் அந்த 7.4 இதுக்கு வரும்போது vertical velocity and horizontal velocity they were decreasing it. So அது வரைக்கும் வந்துருச்சுனால மோஸ்டா நடந்துருச்சுன்னு அர்த்தம். எவ்வளவு பெரிய விஷயம் இல்லை. I have to see what is the exact purpose. I don't know what they are going to study about, but we have to see. தண்ணிக்காக தான், but is there any other property they are going to study is what we have to see. அது ஒண்ணுத்துக்காகனா it will be few crores, no? You have to study and see. So this is the answer. BL square omega by 2 is going to be the EMF. So what about the current induced in it? Current is nothing but EMF divided by resistance. So BL square omega divided by 2 by R. So BL square omega by 2R. Then what about the heat dissipation? Heat dissipation is V square by R. Correct? So heat dissipation, you can write it as E square by R. Again, see the top one is square, okay, not L. E square by R. So E square, right, it is going to be V square L power 4 omega square divided by 2 times R. 2 4 times R. So V square L power 4 omega square divided by 4 times R. Then B square L power 4 omega square. Are you clear with this? Right? Right. This is all about the concept of motional EMF. Dissipated, see, when it is rotating, there is some amount of energy that will get lost in the form of into 10. V square by R, okay. Oh, heat dissipated. I thought I wrote the formula for, sorry, yeah. So heat dissipated means V square by R into time. So you need to put the time here. Correct. So it is B square L power 4 omega square into T divided by 4R. Okay. So this is all about motional EMF, right? So we have, I think, 3 or 4 more subtopics. Self-induced EMF, then mutual induction. And I don't think transformer. Transformer அடுத்த சாப்டர்ல இது இங்க வந்து generator இருக்கு. You will study about generator, and the second and the last one is eddy currents. Van de Graaff second chapter, அது capacitor related. இல்ல deleted. Van de Graaff generator is not there. Okay. So in the next class we'll try to discuss as much as possible. Right. Okay, close it. Any other questions? All clear? Those are online, all clear?
Yes, sir.
Yes, sir.
Wind up.
Thank you, sir.
Thank you, sir.
Bring that problem.